I'm sorry, like it got somehow it got cut. But this is the additional part of that lecture. So what I was saying, this is number one, this is number two. These are the two of the rules. I'm going to clear the board, so it's better if you take a note of these rules. But these are the like simple rules. The rules which now we are going to get into are, the third one is also like sort of the easier type. Let's say we have a function fx. Let's represent this time y as an fx, okay? Because we saw in our last class that we can also represent a function in terms of what? Fx. Now fx is denoted as, let's say, two other function, okay? G of x plus h of x. Let's do it in terms of an example. Let's say we have g of x as 3x plus 4x squared and hx as 2x squared plus 5x cubed. Okay, this is the two equation we have. Now, this is known as the sum rule, okay, summation rule. So when we try to find the f prime of x means dy by dx. So when we try to do that, we're simply going to find the differentiation of that individual function. So we'll find simply g prime of x and h prime of x, and simply we will just add them. Can you find a similarity with this rule and the first rule? The first rule and this rule like implements the same thing, that they have an additional sign, and simply they like the first rule. The first rule we had to find simply the like differentiation of the specific expression, isn't it? The sum rule is simply like enlarging them arithmetically, which we mentioned in our last lectures, that if let's say like the gx itself is following a summation rule, okay? Like no, consider here gx is what? 3x plus 4x squared. So when we try to like differentiate this gx, what do? We individually differentiate them, isn't it? So if we take now 3x as, let's say let's say if we are saying that if like we are saying that gx is denoted as a of x plus b of x, where a of x is given as, let's say, 3x, and b of x is given as 4x squared. So g prime of x should be a prime of x plus b prime of x, okay? Individually we will find the differentiation of, let's say, ax and bx, and we will simply add them. So a prime of x is what? We should get a prime of x as 3, because we know x, like the differentiation of x is what? 1. So we should get 3. And the differentiation of this equation is 4 times 2x, isn't it? That means 8x. Now simply if we just place them over here, what should we get? We should get g prime of x as 3 plus 8x, isn't it? This is our g prime of x. Similarly, if we want to find the hx, h prime of x, we should get, I'm doing it like all together at once, so 2 times x plus 5 times 3 times x squared. This dot sign denotes multiplication, okay? So here, this dot sign represents multiplication. So this 2 times x means 4x plus 5 times 3 times x squared means 15x squared. So this is the differentiation, differentiated value of this hx function. Now, if we want to find simply fx, what do we get? Fx should be g prime of x plus f prime of x. G prime of x, we can get it from over here, which is 3 plus 8. Sorry, this is taking up much space. So here, 3 plus 8x. This is from the gx plus, and from the h prime of x, you're getting 4x plus 15x squared. Okay. Simply just if we add them, we get 3 plus 8x plus 4x, which gives us 12x plus 15x squared. So this is simply our summation rule. We're summing them, the individual differentiated values. This is rule number 3. Now, if we go to certain other rules, also before going to other rules, remember one thing. summation rule does include the addition and subtraction sign. That means the summation rule or sum rule, if we write them as in like in this format, fx is equals to g of x plus h of x, then it also implements like if f prime of x represents, let's say, g prime of x plus h prime of x. If this is the case, then it is also true that fx equals to gx minus hx. Okay, so this negative sign is also included here. Like it implements, yes, the sum rule implements for is like applicable for both the positive and negative signs. So g prime of x minus h prime of x, since they are all like arithmetical, like in the arithmetical form, so it is applicable for all of them. Now, coming back to the most important part of today's lecture is the product rule. This is a new type of rule actually. This is, let's say, which number rule? This is number 4 number rule. So the product rule. So what does this product rule suggest? Now this product rule suggests if f of x is equals to g of x, this is the function, and it is multiplied with h of x, this is another function, they're multiplied, they're product of each other, then f prime of x is represented as g prime of x multiplied with hx addition gx multiplied with h prime of x. So this is our product rule. So what does product rule says? It says if we have a function where we have, let's say, two expression, g of x in one part and h of x in another part, then the differentiation of this whole function fx is the differentiation of that first part, and the other part remains just simply there, like it doesn't change. The hx, we are not differentiating it in the first portion, simply just placing hx over here, but differentiating gx, and we are just producting them, I mean multiplying them with each other. Then we need an additional sign, like we will add with it another portion, which is the differentiated value of the next part of the equation, which is this hx, but this time gx is not going to be differentiated, and simply they are going to be product like multiplied. A simple way to write this is, let's say you have an equation y equals to uv. Okay, then simply if we find dy by dx, this is represented as u prime, I mean sorry, not u prime, du by dx into v plus d, not v, u times dv by dx. Okay, this rule is also like this product rule is also known as the rule of uv. Like oftentimes people say use the uv rule, use the uv differentiation. So uv actually represents this product rule. So that means we will be finding dy by dx in terms of du by dx times v plus u times dv by dx. That means we will differentiate like how do we say? Yeah, we will say it in this way, that differentiating u multiplied with simple v, then differentiating v multiplying it with u. That's how it goes. Okay, let's do a couple of examples so that we can get the gist out of it. To clear the board, let's say we have examples of let's say we have two expressions, g of x as, which is 2x squared plus 3x. Then we have h of x as 4x squared plus 3x cube. Okay, 3x cube here. Now f of x is g of x plus h of x. Okay, now sorry, not addition, they are multiplied with each other. Now, according to our product rule, since f prime of x, we know this should be the case, g prime of x multiply with simple x, hx plus simply gx, this multiplied with h prime of x. Now let's try to find them out. G prime of x, like before doing like whatever I'm doing here, try to do it in this way because this will make things easier. At first, beside gx, try to find g prime of x. G prime of x is what? 2 times 2 is 4x plus 3, and h prime of x gives us the value of what? 8x plus 3 is a 9x square. Okay, so I'm doing it in a shortcut, but for you, consider to do the whole math, like do it step by step. Write 2 into 2x 2 minus 1, or just simply write x to the power 1. Like try to do it step by step so that you have less errors. Because right this time, like right at this moment, you have to learn. You don't need to like reduce the time you are taking to solve the math. Right at this moment, you are like just learning. So you have to learn how to not make mistakes and how to implement the methods properly. Now, implement this each of the term over here. We know g prime of x, like the first term is what? G prime of x times hx. So from here, we know g prime of x is over here, which is given as 4x plus 3. So 4x plus 3, multiply it with what? Hx. H of x is what? 4x squared plus 3x cubed. So 4x squared plus 3x cubed. Okay, addition, g of x, which is given here, 2x squared plus 3x, multiply this whole with h prime of x, which is 8x plus 9x squared. Okay, now if you feel like breaking them up, you can also do like the breaking part, which is in this case should give us 16x cubed plus 12x to the power 4 plus 3 4 is 12, 12x cubed, sorry, 12x squared plus 9x cubed. And over here we should give us 8 to the 16, x cubed, x squared into x is x cubed, plus 2 9s are 18, 18 then x squared times x squared is gives us x to the power 4, plus 3 is a 24, 24 then x times x is square, so x squared plus 3 9s are 27, and x squared into x gives us a value of x cubed. Now if we simplify them, we should get, let's say, which is the smallest one. These are the smallest ones. So 36x squared plus 12 plus 24 is 36. Then we have cube. Cube is 16x cubed, 9x cubed, 16x cubed, 27x cubed. So 16 plus 16, 32. 32 plus 19 plus 27, 36. 32 plus 36 gives us a value of 38 and 68x cubed plus 24 and 18, sorry, 12 and 18, 20, 30, 30 x to the power 4. So simplifying them, we get f prime of x as what? This as the equation, this as the expression. So this, using product rule, it became very easy for us to solve the equation. Otherwise, it would have taken us like huge amount of time. Why? Because gx and hx, we would have to multiply them together. Like if we didn't do the product rule, we would simply use what? We would simply multiply g of x together, broken, like over here, what should we have done? It would be 2x squared plus 3x times 4x squared plus 3x cubed. Like over here, it might have been simpler, like multiplying them, then breaking the bracket, and just simply like using the sum rule to, like we could have done it also in this way. 4 to the 8x to the power 4 plus 2 3s are 6x to the power 5 plus 12x cubed plus 9x to the power 4. Okay, we could have 6x to the power 5 plus 17x to the power 4 plus 12x cubed. From here, like we could have simply implemented the sum rule, differentiation of sum rule. So if we implement dy by dx over here, we could have like easily got the answer. But when the sums are bigger, when the like expressions are very bigger and complex, on that time, like this sum rule becomes very difficult. For example, let's do that example which I show in the like starting of this class, which was, let's say, it was something like y equals to x squared. We have root over 4x plus 6 whole cube. In this scenario, it will be very difficult for us to use the, like breaking the bracket and using the sum rule. So how do we do this? We simply use the g of x and like f of u of like h of x, or you can say simply the u below. Or previously we just simply use g of x and h of x. Let's do it in the form u and v. From here, we have to consider any one of them as u. So let's consider these as u, and let's consider this whole as what? V. So u prime is equals to what? Or dy by dx represents what? It's du by dx. Sorry, du by dx represents what? 2x, isn't it? And over here, if we writing the v over here, simplifying the v at first, v equals to 4x plus 6. So remember, root over of anything means actually the power is half, okay? Half of the power. And we have a whole power of what? 3. We can write this in this way. 4x plus 6 whole to the power 3 by 2. Okay. Now things will be much more simpler. So over here, v is this. Now differentiating v. Now, before differentiating v, there's one more thing we should deal with first. Before solving this equation, okay, this is a bit advanced part. Like before, here are actually two rules implements. Here, one of the rule is obviously the product rule over here. But before going to learn that, we need to know actually first how to differentiate this expression as a whole. Why? Because see, over here, the power 3 by 2 is not only simply on the value x, isn't it? And if let's say we have the function like ax plus b whole square, we could simply break it as what? Ax whole square plus what? 2 times ax bx xb, I mean ax into b plus what? Bx squared, isn't it? A plus b whole square's formula. If we break them, we get this formula, isn't it? So if the power is a whole number or the power is a square, we could have simply done that easily. But since this power is not a like whole number or some good looking number, that's not possible. Then we need to implement binomial equation. But simply implementing binomial here like won't work because binomial takes itself a much longer time. And differentiation also takes much longer time. So implementing both together in same place would cost us a lot of time. In this case, to reduce that time, we'll be using or we'll be implementing some other methods. So that method itself is known as the chain rule. So now let's learn actually how chain rule works. So before coming to this, solving this equation, let's take a note of this equation. This x squared 4x plus 6. Okay, we will be coming back to it. Let's write it over here. X squared 4x plus 6 whole cube. We'll be coming back to it. But before coming back to it, let's learn the other rule, which is the fifth number rule is known as the chain rule. Now, how do we define it? Let's work with this. Let's work with a simpler term. Let's say we have an equation f of x equals to g of, let's say, yes, g of x. Yeah, g of x. Now, this x itself, or the inside of the g, is another expression, or the input of g is another expression, which is h of x. Does it make sense? At first, let's learn the concept of function at first. Let's recap it. Function means what? F of x means, because let's say if a function is f of x equals 2x plus 3x squared, what does it mean? This means this whole expression can be represented as fx. Now, if this is fx and we say when x equals to 2, what is the value of f of 2, isn't it? That means what? When the input is 2, when the x value is 2, what is the value, isn't it? That means instead of this fx, we're placing in that x, the input value is what? 2. The input value is going to be 2. So that means in this expression, when we place 2 inside, what is the value? So that means 2 times in the value of x, we place 2 plus 3 times 2 square. We're inputting the value 2 in place of x. We're getting 2 to the 4 plus 3 into 2 square, 2 to the 4. 4 times 3, 12, giving us a value of a total of 16. That's how it works, isn't it? Now, let's say similarly, g of x is something like that. Let's say some equation. Now, if that's the case, then if we are, let's say it has certain equation, like it has certain form. Okay, we're not like we're not dealing with that, but it does have certain equation or certain form. Okay, now we are saying that g of x, that inside we place another, like the input is given, let's say h of x. Okay, the inside is another function. Then how do we deal with it? Let's simply give an example. It will be easier for us if we consider two different values, like I mean two different expressions, different terms here, because giving all as x becomes very difficult for us to handle them. So let's say instead of g of x, we have g of a. Okay, if g of a is here, let's say the equation a is something a to the power 3/6. Okay, and that a represents another function. Let's say it is h of x, another function, where hx is given as, let's say, 2x plus 5. That means what? That means if in place of a, we place hx over here, what will happen? Try to observe that in place of a, if you simply replace that a with this hx, so simply placing that h of x inside that g, that means what? In place of this a also, we need to place hx, isn't it? That means h of x whole to the power what? 3/6, isn't it? And h of x is what? This 2x plus 5. So in place of hx, we will place, just simply substitute 2x plus 5. That should give us a value, something like this, isn't it? So that means this whole thing was an expression or was a function when that a itself is another function, which is h of x. That is what represented as that whole. You might get confused. So for that, let's do it again. Let's explain the situation, the scenario again. So basically, what I was trying to say is, let's say we have this g of a as a function, where a is noted as, let's say, some a square. Okay, let's make it much simpler. So this is another, like this is an example. So g of a is equals to a square, or f of x is equals to g of a, which is equals to a square. Okay. Now that a itself is another function, which is what? H of x. Okay. Now h of x is represented as, let's say, 2x plus 5. Okay. Now simply if we substitute this a over here with this hx, what do we get? Then g of hx, isn't it? That means function inside a function, because g was itself a function and hx itself is a function. So we are substituting this function, I mean, we're substituting this function in place of a. So what do we get? We are getting over here hx to the power square, like simply just placing hx at first over here, substituting the a with hx. And now when we substitute that hx with its actual equation, what do we get? Let's say we are not changing this over here. We are just mentioning h of x is this. But if for simplicity you want that, you can also say that 2x plus 5, substituting that whole term, like that whole hx with what? 2x plus 5 whole square. So that's our equation, isn't it? So that means function inside a function. This was itself a function, that's another function. So in order to do so, like if we want to find f prime of x, then we need to do two things. One is we need to find the g prime initially. G prime, we have to find it. Okay. If we need to find g prime, obviously we are not going to deal with hx at first. Okay. But eventually we also need to differentiate that inner part as well. So how does it work? Again, let me show it. So it says if we have a function of, let's say, g h of x is equals to 2x plus 5 whole square. That means what? That hx, like we are having two expressions here. So if we need to find h prime of x, we have to apply g prime over there, like on the whole equation, but keeping hx constant at first, because we are implementing differentiation on the outer function. We're implementing the differentiation on the outermost function at first, then multiply with itself the inner function's differentiation. Does it make sense? Let's do it in the previous way. Like, let's try to do it in the previous way, which was, instead of writing hx at first, let's consider a initially. So we have what? G of a equals to a square. Okay. Now, initially, when we are trying to find the g prime of a, what do we get? 2 times a, isn't it? That's how it works. Now, if we are trying to find the a as hx, which is 2x plus 5, and we try to find the h prime of x, what do we get? 2, isn't it? Because 2 times 1 times x to the power 0 plus 5 times 0 times x to the power minus 1, because here we have an imaginary x to the power 0. So that gives us a value of what? 2. Now that is h prime of x. Now, if that is the case, then according to that chain rule, what do we need to do? We are first finding g prime of the equation. Now g prime of equation is this one, isn't it? And g prime of equation is this one. That means that's, yeah, g prime of equation is this one. And we know when we first do this, g prime of a times the a prime, what do we do? And a prime is what? A prime means h prime of x. So g prime of a is over here, which is given as 2 times a. So 2 times a prime means what? Simply 2. A prime means simply 2. Now substitute the value of a with its actual function, gives us what? 2 times 2x times 5 plus 5 into 2. So that gives us a value of 4 2x plus 5. Now see, over here, this was what? This was actually the g prime of x, and this was h prime of x, if that makes sense. Let's do another time, but this time consider h prime of x instead of like the a. We will do the same math with h prime of x. Like instead of writing a, we'll be trying to do it, solve it with h prime, like hx. So we have the function g of hx equals to some function which is 2x plus 5 whole square. So this, like the outer part, this outer part, like not the part inside the bracket, just simply let's say the red, like the part which is outside this red bracket. Okay, this red bracket, that's itself is a function. So consider this as a whole, like let's say this is a. So this is a function itself. So that is we are going to be like differentiating at first. So that is what g prime of x means. I mean g prime of anything means. So g prime means 2 times this function, which is something, let's say whatever it is, so 2x plus 5, whatever it is inside. Let's replace that with green because it will be easier for us to understand that we are dealing with. This inner part is another part of function. So here we should get what? The power comes in the front. This power comes in the front, then 2 minus 1, isn't it? Now we are dealing with that part which is multiplied with h prime of x, isn't it? The inner part. So that is going to be differentiated as 2 into the differentiation of x is what? 1 times x to the power 0 plus what? 5 is 5 times 0 times x to the power minus 1. This gives us a value of what? Like this is as a whole. multiplied with it. So this gives us a value of 2 times 2x plus 5, and this gives us a value of what? Into 2. So that's how our differentiation works. So in our next part of the video, we'll be doing some more elaborate math, and we'll be solving this one.